Good morning, girls. We will continue the exercise 7.3. And in yesterday's video, I had explained you SSS congruence and RHS congruence. Right now, today, uh, in the next question number 2, it says that AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. You have to show that AD bisects BC and AD bisects angle A. So, for this, let us draw the figure. Question number 2, exercise 7.3. We have a triangle. We have a triangle ABC. Now this is an isosceles triangle, so AB will be equal to AC because it is given that AB is equal to AC. Then this is the altitude AD, right? Now when the altitude is given, an altitude is always perpendicular to the side on which it drops. So therefore, this angle ADB and ADC will be equal to 90 degree, right? Now we have to prove that AD bisects BC, that is we have to prove that BD is equal to DC, and we also have to prove that angle BAD is equal to angle CAD. Okay, for that we have to prove the congruence first. So let us check out which congruence we are going to use here. Now in triangle ADB and triangle ADC, the first point is AB is equal to AC, which is given because the triangle is isosceles. Number 2, angle ADB is equal to angle ADC 90 degree, as AD is the altitude. You have to mention each and every reason. Then the third side is, now which side you will see for the third congruence condition? It will be AD equals to AD, right? Now you have got this side, that is hypotenuse and this angle. So the congruence which is used here will be triangle ADB. Triangle ADB is congruent to triangle ADC by RHS congruence, right? Now when the triangles are congruent, children, you know that the corresponding parts are all equal. So we can write therefore BD is equal to DC. Yes, so therefore we can write AD bisects what? BC, and we can also write here that angle DAB is equal to angle DAC. Angle DAB is equal to angle DAC, which is equal to, which is, the reason will be CPCT. Here also the reason will be CPCT, corresponding parts of congruent triangles, and we can therefore write AD bisects what? Angle A. So this is what we had to prove, and so this completes your question number 2. So again, triangle ABC, which is an isosceles triangle, AB is equal to AC given. BD is the altitude which is dropping on BC. You have to prove that BD is equal to DC, that is AD is bisecting BC and AD is also bisecting angle A. So we will first use a congruence condition, that is the RHS congruence criterion, and then write these two parts as a corresponding parts of the congruent triangles. Now coming to question number 3. Now as you can see that two sides AB and AC, let us see the figure first. Two sides, you can see the triangle, two sides AB and BC and median of one triangle are respectively equal to PQ, QR and PN, that is a median of the triangle PQR. As you can see that the corresponding parts are equal, yet they have shown with the symbols. You have to show that ABM is equal to PQN, that is congruent, and triangle ABC is congruent to triangle PQR. So let's begin with the proof. First I'll draw the diagram. Question number 3. By the time you can think of which congruence criterion we are going to look for. Obviously this will be SSS because all the three sides are equal. here A, B, M and C. So as you can see that A, B, M and C, and here this is P, Q and R, and this is what? N. Now AB is equal to PQ, which is given, AM is equal to PN, and BM is equal to QN. Now very simple, the first part is in triangles ABM and triangle PQN. Number one, this is the first part. Number one, AB is equal to PQ, which is given. Number two, AM is equal to PN, also given, right? And third part, BM is equal to QN, given. So therefore you can see that all the three sides are equal. Therefore triangle ABM will be congruent to triangle PQN by SSS congruence. Now children, we have to prove that ABC. Okay, second part you have to prove is triangle ABC is congruent to triangle what? PQR. Now to prove that the two triangles are congruent, when I take A, B, C and P, Q, R, after proving these two ABM and PQN as congruent, we can take some corresponding equal parts, and then that corresponding equal part we can use in the next part of the proof. So now as you can see that if I take the whole triangle ABC and PQR, okay, AB is equal to PQ, which is given. Now we can prove that BC is equal to QR. You know how? Now children, you know that this is the median, AM is a median, PN is a median. Now median is actually dividing this whole side into two equal parts. Similarly, it is dividing here also. Now one part, that is half part of this triangle, is equal to half part of this triangle. Okay, you know that BM is equal to QN, which is half of BC, and this is half of QR. Okay, so we can write, let's cancel this first and write BM is equal to what? QN. What is BM? Half of BC, and this is half of PR, not PR, QR. Okay, now I can cancel this half, therefore BC is equal to QR, and therefore we have proved by which, this is how we have proved, so we need not write CPCT. Now one side is this one, BC is equal to QR. Now can we take some other angle? Okay, now if I take triangle ABM and PQN, because these two triangles are congruent, I can write that angle B is equal to angle Q. Okay, so right, did you follow what I am saying, children? Angle B will be equal to angle Q, and that is CPCT. Now we have got three parts. So now we will consider the triangles ABC and triangle, which one? PQR, right? First point, AB is equal to PQ, which is already given. Yes. BC is equal to QR, I can write proved above. Yes. And even the third part. Now if I take this angle, this side, and this angle, so angle B, third point will be angle ABC is equal to angle PQR, which is by CPCT. Now the three parts we have got, so we can write, therefore, triangle ABC is congruent to triangle PQR by which congruence? Side angle side. Okay, so children, this completes your question number, which one? 3. So first what did we do? We first take all the three equal parts of the triangle ABM and PQN. Then we prove them to be congruent by SSS criterion. Then we take the corresponding equal parts. Angle B is equal to angle Q. And then we also prove that BC is equal to QR, because BM is equal to QN, which is given. Half of BC will be equal to half of QR, and therefore we cancel halves. So the three corresponding parts which we have got proves that the two triangles are congruent. Okay. Similarly, we have completed the second part, by which congruence? SAS congruence. Okay. So this is question number 3, and I hope it is clear to you. Now question number, which one? 4th. Question 4th is also very simple. It is saying that BE and CF are the two equal altitudes of the triangle ABC. Using the RHS congruence rule, you can prove that the triangle is isosceles. Okay, so let's draw the figure. Question number 4. Equal altitudes of triangle ABC. Okay, not here. I'll draw it at this side. This whole proof has been completed. Now question number 4. In the triangle ABC, BE, this is BE, and this is CF. Okay, these are altitudes. You know, altitudes are forming 90-degree angle. Yes. Now they are equal. So we can write in triangle ABC, BE is equal to CF, and they are perpendiculars, or their altitudes, so I have shown with the 90-degree sign. Now we have to prove Nacha. They have also given that you have to use the RHS congruence. So they have given you which congruence to use. Then we have to write that the triangles are congruent, and then you have to prove that ABC is an isosceles triangle. For that we have to prove AB is equal to AC. Children, I hope you are understanding what I am doing. Which triangle is given? ABC. BE is equal to CF, which is given. Using the RHS congruence, we will prove the two triangles to be congruent. Now, which two triangles we'll consider? We will consider triangle, you know what? BEC. Triangle BEC and triangle BFC. Okay. Now, when I take BEC, BE is equal to CF. First point. BE is equal to CF, which is given to you. We have to use RHS, so you have to specify on the right angle now. Right angle is which one? BEC is equal to BFC. Angle BEC is equal to angle BFC is equal to 90 degree, as those BE and CF are altitudes. You will write the reason properly in your notebook, then only you will understand. Otherwise, you will forget. Third point. BC is common for both. You can check out BC is common for both the triangles. So BC is equal to BC common. Now, can you see that this is RHS? Yes. Why? Because there is a right angle. Then this is a hypotenuse, because for where is hypotenuse? Hypotenuse is always opposite to the right angle. So this is the hypotenuse, and these sides are equal. So yes, it is correct. Therefore, triangle BEC is congruent to triangle, which one? BFC by RHS. Now when the triangles are congruent, children, when the triangles are congruent, the corresponding angles are equal. So what I'm going to do is, in this triangle, when I see E, if I see B, E, C, so I'll mark this angle. Okay, and when I take this triangle, which one? B, F, C, I will mark angle B. Okay, so now I will write angle C is equal to angle B, CPCT. Now, when the two angles are equal in a triangle, the sides opposite to them become equal. Therefore, AB is equal to AC. What is the reason? Sides opposite to equal angles are equal. In which triangle? We are talking about isosceles triangle. Therefore, triangle ABC is an isosceles triangle. So simple proof, you have to first analyze the question, see which triangles we are going to take. Don't take these triangles A, B, E and A, F, C, because you will not get anything out of it. So you have to consider the triangles which I have taken here, and then we begin with the proof. Okay, so this completes your question number 4, and I hope, children, you have understood these 3-4 questions. Now one last question, that is this one. Triangle ABC is an isosceles triangle. I'll draw the figure, not given. 5th one. Triangle ABC is an isosceles triangle. AB is equal to AC. Okay, so again the same similar type of triangle ABC, in which AB is equal to AC. Draw AP perpendicular to BC. Yes, so I have drawn AP perpendicular to BC. What do you have to show? That angle B is equal to angle C. This is what we have to show, and let's begin with the proof. Now it is saying that this triangle is isosceles. So very simple, yes. Proof. Triangle ABP and triangle ACP. ACP. First point. AB is equal to AC, given. Now you know, children, that this one APB is equal to APC. These are angles equals to 90 degree. And why 90? Because it is an altitude. So you will write the reason. AP is perpendicular to BC, which is given in the question. Now what is the third condition? AP is equal to AP common. Yes, AP is equal to AP common. AP is equal to AP common. Now which congruence is this, children? Just check out. Side, hypotenuse, right angle. Side, hypotenuse and right angle. So again, therefore triangle, which one? ABP is congruent to triangle, which one? CP by RHS congruence. So when the triangles are congruent, children, you can say that angle B will be equal to angle C and CPCT. So therefore angle B is equal to angle C. Just write CPCT and write hence proved. Okay, so I hope, children, it is clear to you that this whole exercise is based on the congruence SSS and RHS. In between we have got conditions where we have to use SAS and ASA. So that is okay. So this is complete 7.3. Today you revise everything, and tomorrow I will take up some more questions from the similar type of congruence. Okay, and then we will study inequalities in a triangle. Okay, So study all this, and I hope all the proofs are very simple questions. These are very simple questions. All the proofs, I hope they are clear to you. Any doubts you have, you can ask me. Okay. Thank you. Have a nice day.